So what this question is saying about is kth largest element in an array. It will give position. What will be the kth one? Like in this array. Second largest element, for example. What is that? This is the first largest. This is first largest. And this is second largest. This is the third largest. So basically, first largest is the most maximum largest element in the array. And other ways, what we can think of is this is the first smallest element. And this is the second smallest. This is the third smallest. So what happens is the smallest elements get larger as the number of the first, second, third increases, and the largest element gets reduced and shifted backward side whenever there is a kth largest or something like that. So in this problem, given an integer array nums, return and an integer k, return the kth largest element in the array. For example, this is the first largest, second largest, third largest. So the basic solution for this is sorting. Like here we were given number 321564. We will sort it and we will check the position of the kth largest from back. Let's say if it was 2, then this will be the second largest. So sorting is one of the approach, but heap is a better approach for solving such type of questions, because sorting will be applied and on the whole nums array of length n, and thus the sorting time complexity will be n times log n for entire sort, n log n. And that's not good. While I guess the time complexity for heap is n log k, so that helps. So we have to return the kth largest element. So largest will be returned using the max heap. By default, we know that Python has only min heap, and min heap is defined under the heap q function, heap q library, and min heap returns the minimum element on the top. Like for example, this is the array, then on the top always will be the minimum element. While to make it the max heap, what we do is like we know by default Python has only have min heap and used with heap keywording, right? And we are using min heap for k largest element and popping off. So and we use max heap for the kth small. So in this approach, what we have done is like we are solving it with min heap this time, and with min heap we have this PQ. This is a array that we will be making up, converting it to heap. And for every element in heap nums, we are pushing it. So it will get stored and the minimum value gets stuck at the top. That's what min heap does. And if the length of PQ becomes greater than K, like on the top, we will keep minimum elements. So basically, what's the idea of this max heap is we will have a max heap at min heap. In the min heap, always the minimum element will be at the top, and maximum elements will be safe at the bottom. So the most maximum element will be at the most bottom point. Then on top of that, second most largest element, third more largest element, fourth largest element, till, and above we will have the minimum element. So as long as this length is less than k, we will keep adding. And if the length becomes greater than k, we will pick it up and throw the minimum element. So this way, what happens is all the minimum elements get picked up and thrown away, while the k of the most largest elements stay in the bottom of the heap, and the most greatest element will be staying at the bottom. So let's read this min heap approach. We know by default the Python have only min heap with heap keywording name. Yeah, we know. And we are using min heap for k largest and keep popping off if length exceeds k. We use max heap for k smallest element and keep popping if the yeah. And we use, and while simulating a max heap, we will push it with a -1 of x. That's the thing. And popping that minus is multiplied. So let's look at this min heap approach. What we are doing is we are putting up elements in the PQ, and as we are using heap push PQ, that is the name of this PQ array, and we are pushing the element. And if the length becomes greater than k, we are just popping it off, and at the top it is the PQ of 0. And let's say if we want to return the k largest elements, if the question was to return k largest elements and the order doesn't matter, because we know in a heap only the guaranteed thing is the top of the element, that it will be minimum if it's a min heap, or it's a maximum if it's a max heap. The ordering of the middle elements is not concretely defined, like it doesn't guarantee the sorted order in the left of the bottom of the heap. Like if this is a heap, if this is a min heap, and its length is k. So here larger elements, the the smallest at top, because it's a min heap. And the smallest is at top, then greater than this one. Like let's say if it's a 1, then here will be 2, and let's say here will be 14 or something, or here will be 5 staying up in the min heap. And let's say we found out a new new element that is 0. So we will insert it here, but we will insert it here, and this one will be removed this way something. So that's all the crux of using the min heap approach. Another approach would be max heap. We are popping it off. I guess this one should work. It's heapify. So basically, we have seen two approaches for solving this question. One is with max heap. I will prefer this one. And this one is the min heap. And you can see that here we are pushing elements, all the elements with minus sign. In max heap, it's a standard practice that we push elements with minus sign, so that let's say if the numbers are like 1 comma 2 comma 4 comma 7 comma 8 comma 5. So after taking up this minus sign, this will become -1, this will become -2, -4, and this will become -7, -8, and -5. So this will be the p cube in the max heap thing. And when we will heapify it, it will look something like this. -8 will be at the top, then -7, -5, then -4, then -2, then -1. And let's say we want to find the k is the second largest element. So let's say third largest. So we know that the answer is 8 is the first largest, 7 is the second largest, and 5 is the third largest. So our answer should be 5. So what we will do is we will pop off k minus 1 times. So when we will pop off, this is the minimum element because it is pushed with a minus sign. So it will come out and it will get popped. So yeah, this got popped. And we are doing it 8k minus 1 times. We have done it one time. Then again we will pick up and remove it because -7 will be at the top of the heap, and when it will come out it will get popped, so we will remove it. And now at the top of this heap, this -5 stays. We will pick it out and we will use a minus of -5 that will return us +5. That is the answer, which is the third largest. So that is the whole funda behind the maxi. Let me just submit it. So let's see the find the kth largest integer in the array. Find the kth largest integer in array. Find the kth largest integer in the array. So you are given an array of strings nums and an integer k. Each string in nums represents an integer without leading zeros. Return the string that represents the kth largest integer in nums. Note that duplicate numbers should be counted distinctly. For example, 1, 2, comma. So there is no like this the second largest element. First largest is 2. Second largest again is 2. It's not that we are using some set type of shit. So what we are using it here is kth largest. And this approach is good. We are not using heapify, heapq.heapify, pq. We are using heapq.heap push. We are just pushing directly. So let's look at this approach. We have used a pq array, defined it, and for element in nums, for string in nums, we are pushing the integer value converted of it. Like this string of 3 will be converted into integer of 3. This string of 6 will be converted into integer of 6, and all that. We are pushing it, and all these elements will be fed up in our pq array. And if the length of pq exceeds k, we will just pop off all the above useless smaller elements, and the maximum elements is if the min heap. So the point to remember is in min heap, all the larger elements stays safe, while the smaller elements are picked off and popped off, and the larger elements stays safe at the bottom, and at the most bottom, the most largest element stays safe. And on yeah, so and on the top will be the kth large. So we are pushing it, everyone, and we are popping off as soon as the length of that increases, and we are returning the this one. So this is using the heapq.heap push. And there is another method. Instead of just pushing all the elements and doing this, first we convert it into a full heap of the full nums array. So what heapify will do is it will convert the array into a min. So this heapify function, what does it do is it converts the array into a heap. That means it heapifies it. So and this bottom part is just same. This bottom part of heap.heapify, heap pop of pq. This shit is same. So this shit is exactly the same, and this heapify is converting it this pq array into a heapify. And let's read what the points I have written. So no need of a set here because distinct things doesn't matter. Earlier I was thinking that distincts are counted, like this 1 2 2 should be converted into only of two things in a list, that is 1 and 2. We are just using one of them, but distinction is not a case here. And kth largest, we will use a min heap and pop off all the useless minimum elements from the top while keeping larger elements at the bottom. And this is the we can solve it with maxi pop. So let's write the code of maxi pop. So we are gonna use, and no need of this much. Heap.heapify has been done, and we are appending it with minus of integer x. So let's run this and see it's working fine or not. I guess it should. Wait. We have to return string here. Yup, this is working fine. Exactly. We have made a max heap and we are appending with uh, this negative sign. And we are using this for loop. What we can do is we can use a counter equals and while counter less than keep pop EQ counter plus let's see if this works or not. Let's start it with yep. This is another counter base, but I prefer this for dash loop. So this was the code for using Maxi. You have seen the approach for min heap and we have also seen the heap min heap with two approaches of heapify and without heapify we are using. And let's see this one.